All right. So 3.2 exponential and logistic modeling. What? You can see that Garrett's watching it too. Garrett, can you see this? Can you see the whole pink paper? Oh, it's like that because that is what you can see because it's backwards. The camera's backwards. Is that better? Okay. It's going to take the whole class period to figure out the video. Okay. So exponential population model. If a population P is changing at a constant percentage rate R each year, then P of T is equal to P sub 0, 1 plus R raised to the T, where P sub 0 is the initial population, It's actually getting it? Well, that's good. R is expressed as a decimal, and T is time in years. I wonder, I'll have to play around with it and see. I wonder if it would let me screen share my notes app, and then I could just write all my notes on my iPad. I don't know if that would work or not. I'd have to get an Apple TV to share it up to here. I don't know. I'm just curious. Get the Oculus thing. I mean, I don't care. Is it clear? I haven't really used my iPad for camera. Sub-zero. What? Just need to make sure I'm not needing to let Melcher in. I don't understand why the camera's backwards. Like, that's what I don't get. I don't know. The camera's just backwards, though. Like, it was backwards, like, when I, like, had it on myself. Yeah, but I don't know why, because it's a front-facing camera. Or rear camera, whatever. Maybe, I don't know. Alright, we'll look at a couple examples of this as we go. Okay, so everything has to be in this form, this P sub 0 times 1 plus R raised to the T. So that's what we're looking for with these growth and decay functions. So 2 through 6, say to tell whether the function is exponential growth or decay, find a constant percentage growth or decay. So number 2. What? Yeah, we're going to kind of do, this section we're going to kind of like mix examples in as we go a little bit more. Plus there's not quite as many notes in this section, it's more example filled. Alright. P of t is equal to 4.3 times 1.018 raised to the t. Okay, so this 4.3 is our P of 0, or P sub 0 is 4.3. Yeah, this is multiplied here. 4.3 times 1.08 raised to the t. So we know based on this formula, the 1 plus r raised to the t, so this number has to be equal to 1 plus r. Okay, because it's already raised to the t, and we have this one raised to the t. So we're going to have 1 plus r is equal to 1.018. So then we want to figure out what r is equal to, so I'm going to subtract 1. So r is equal to 0.018. And remember, r is going to be a decimal, okay, and it's greater than 0, so, or, well, in this case it is greater than 0. It doesn't have to be, but in this case it is. So it is an exponential growth function. Okay, with a growth rate. Okay, so the growth rate is always going to be a percentage, okay, or decay rate is going to be a percentage. So if I want to make 0.018 a percentage, what do I need to do? Yep, move the decimal 2 places to the right, so that gives me 1.8% growth rate. Somebody will have to tell me if Garrett does, because I can't see it. Yeah, well, that's what my cousin said, because she teaches math in Louisiana, and she said she uses Google Hangouts, Google Video, or whatever through Google Classroom, and I was like, oh, like, I'll have to think about that. Completely forgot you could do it. Yeah, she said it was new for this year for them. I thought they paid for it, but I guess it's free, or our school's paying for it. All right, number 6, g of t. So it doesn't matter what this variable is out here. It doesn't have to be a p. It just got to be in that form. Is equal to 43 times 0.05 to the t. So what is my p sub 0? P sub 0 is 43. How about my 1 plus r? 1 plus r is equal to 0.05. So what is r? Positive or negative? Negative 0.95. Okay, meaning this is what kind of a function then? Okay, a decay function. This is less than 0. So it is an exponential decay function. And then what would my decay rate be? Wait, what'd you say? And what'd you say?
I said 95.
Yeah, because you have to move it 2 places, so it's going to be a 95% decay rate. Okay, because we don't want to have negative percentages, so we're going to say a decay rate of 95%. Okay, so the other one we said was a growth rate because it was positive, and in this one it's negative, so it's a decay rate. Okay, so the sign just tells you growth or decay, and that's it. Alright, so then, let's see, 7 through 18, we're going to start with number 8 here, and I think we might have a few more notes before we can do a whole lot more. It does. I didn't know if it'd be able to hear me. I thought I might have to put my AirPods in, like, one ear so it would pick it up. Does it get the laugh, though? No? Okay. Alright, so number 8. So we're determining the exponential function that satisfies the given conditions. So the initial value given to us. Alright, initial value is 52. And we are increasing at a rate of 2.3% per day. Okay, so this is going to be what kind of a problem? Growth or decay? Okay, it's going to be a growth problem. Okay, so I'm told what my initial value is. Okay, it's 52, so this is my P of 0, or P sub 0 is 52. I need to know what R is equal to, so how would I find R with this given information? Or ideas on how I would do that? Yes, move the decimal places 2 places to the left. So that would mean this is 0.023. Okay, so that's the rate. And then what do I need to do to actually get, well, that is R. But if I need it in this form up here, I'll go back down in just a second. If I need it in this form, what do I need to do to get this number? Okay, so this is going to be plus 1, so 1.023. So then to actually write it in the correct form, we're going to have P of T is equal to 52 times 1.023 raised to the T. And we're done. Good job, Logan. Don't want to kill your battery, though. Alright, number 10. Initial value. I'm not even sure what my iPad's on. I think I charged it. Alright, the initial value is going to be 5 for this problem. And we are decreasing at a rate of 0.59% per week. Okay, so what kind of problem are we dealing with here? Okay, it's a decay problem. So number 8 was growth. This is going to be a decay. So what is P sub 0? P sub 0 is 5. How about R? And positive or negative? Negative, because it's a decay. Okay, so it's decreasing, so it's going to be negative. We need to move the decimal place 2 places left. So R is going to be negative 0.0059. And then to get the 1 plus R, what do we need to do? Add 1. And so that gives us, just so we don't have to sit here and subtract it out, it gives us 0.9941. So then my formula is going to be P of T is equal to 5 times 0.9941 raised to the T. That's how public schools went back to school. They literally said, you can come back to school in person, but you're going to watch the class on your device with headphones in, and you can't talk. So I had a bunch of friends that planned on going back on the hybrid schedule, and they were like, yeah, I'm not going back. They're like, why would I go sit in class to watch my math class? The same thing online. I can't watch my teacher in person. Yeah, they were supposed to have separate teachers, certain teachers for the hybrid in person, and then certain for the extremely exclusively virtual. They were like, why would I go back? Let's see. If I had my AirPods in, it probably wouldn't do that. Alright, let's look at an example, and then that'll get us ready for stuff tomorrow, and then I'll go ahead and give you guys a few problems to start working on. Everybody has this, right? Okay. This section, honestly, this chapter really isn't too bad in the grand scheme of things. This should be a pretty easy one. Alright, so example, suppose a culture of 100 bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will be 350,000. Alright, so obviously we don't necessarily just want to keep multiplying stuff until we get what we're looking for, right? No, not super fun to do, so we really don't want to do that. So we know that it doubles every hour. Okay, it starts with 100. And we want to know what will happen when we have 350,000, or when, at what time will we have that many? Okay, so we want to make some kind of a little model to predict what's happening. So we know that it starts with 100. So at 0 hours, we have 100. Okay, so if it doubles after the first hour, then I have something like 100 times 2 to the first. Okay? So it doubles after the first hour. So at 1 hour, we are at 100 times 2, it's 200. Okay? Then it's going to double again. Okay? So this becomes 100 times 2 squared, okay? Because remember, in reality, this is 100 times 2 to the t, where t is the number of hours that have gone by. Okay? So, how many do I have after 2 hours? 400. Okay, so at the 3rd hour, I have 100 times 2 cubed. So how many do I have? 800. Okay, and I'm not going to do this all the way down until I get 350,000. That's going to take way too long. Okay? So, I know then that it follows this formula. So P of t is equal to 100 times 2 to the t Okay, and I want to know basically when P of t is 350,000. So I'll replace the P of t with 350,000 is equal to 100 times 2 to the t. So I need to solve for t. How would I do that? Divide by 100, is that what you said? Yep, so that is what I want to do. So dividing by 100, what does that do to this side? Okay, it takes away 2 zeros. So 3,500 is equal to 2 to the t. And now how do I get t by itself? Does anybody remember from last year? I think this is what we did while we were quarantined, so I don't remember. Okay, so I need to rewrite this so that I can use that little trick. I'm going to write 2 to the t is equal to 3,500. And then I need to go from an exponential to a logarithm because I've got to get rid of this t up here, and the only way to do that is to use the logarithm. So I draw my L, so I start up. I'm going to try to do this. I'm going to start up here, and I come down through the 2. I go over to the 3,500, then up and back to the t. So this gives me the log base 2 of 3,500 is equal to t. And then you would need your calculator for that. Just for the sake of time, and since I don't think we have our calculators out, t would be equal to 11.77. Okay, now that's 11.77 hours. You just know off the top of your head what 0.77 hours is. Okay, so I really want my answer written in hours and minutes. Okay, if you were to leave it like this, I'll try to remember to just be lenient with it and let you do that. But I would like your answers in hours and minutes. So 0.77 hours is 6.2 minutes. 46.2. Yes. How'd you get that? Okay, 0.77 times 60. Okay, so that's 0.77 of an hour times 60 gives 46 minutes approximately. So then we have 11 hours and 46 minutes is our official answer. Okay. Well, you might, because we're going to do more word problems. But that's just kind of an intro getting us ready for tomorrow. I'm going to go ahead and give you guys a couple problems of what we've done so far to work on that. We'll do another example similar to this at some point tomorrow. Let's see. What problems do I want? Let's go 1, 5, 7, 9, and 13. Okay, and all this will be due again just at the end of the chapter, so if you have something else you want to do for the next 10 minutes, that's fine. Or whatever. We may finish this chapter, or this section tomorrow. I'm not 100% sure. But that's where we're at for now.